Hey folks, my name is Dave. Welcome to my shop here at NTD Racing. If you watched the last video, we were starting the spindles on our latest build we call Lefty, which is going to be our budget trophy truck. And today we're getting into the fabrication, my favorite part. Now we're hopping on to the Langmuir Systems CrossFire XR. We're going to try to dial in the perfect speed to cut 1/4 inch plate steel and then cut the parts for the spindles and see if we can get those things together. Let's go ahead and get to this build. To start with, on the plasma table, what I got to do is I got to cut some spacers that are going to basically go from this flange right here and then clear the top of this lip right here. And that ends up being about 1 inch. So what I'm going to use, a stack of 4 1/4 inch plates. I'm going to cut in here to basically the design to fit these bolts to go through, and then also the center of the hub to bearing to go through also. And then I'm going to have them cascade out about 1/8 of an inch as each subsequent plate is stacked on top of each other. So it makes it a little bit easier for those to weld those things together. I'm going to start this off with a whole bunch of CAD right here to make this plate and dimension it out and really to set the speeds and the pierce delay that we're going to be cutting these parts off of. I won't bore you with all the CAD. If you want to see the whole version of this, I will put it at the very end of this video. You can watch that, but let's go ahead and get to the different cut speeds and see how they do on the CrossFire XR. All right, we're ready for this first cut. You can see the part is in there and it's all ready to go. It's zeroed at the very top. You got to make sure before you hit this thing, you've zeroed all your axes out. And then over here on the machine, I've got everything ready to go. I have a mostly brand new nozzle in there and a new electrode. You can kind of see the ones that I pulled out of there. There was the electrode. It was looking pretty bad, the nozzle also. So I replaced those. Still filling up the water table with a little bit of water right now. It's full enough for this first cut. You can see I got the compressor ready to go. I'm running full pressure all the way to the machine. So right now it's about 130 PSI. It's going through my Harbor Freight air dryer, which has been working awesome. And this thing's all ready to go. So let's go ahead and make the first cut, see how it does, and then figure out what we're going to change on it. You see the edges, they're really sharp besides where the dross is at. And from this, I think I can just go ahead and speed the machine up just a little bit more to have that thing cut just a little bit faster. Besides that though, it's looking pretty good. All right, a couple thoughts as we get into cutting this thing. And I'm ramping up the speeds here, trying to get the dross down a little bit more. And you'll see as I go through each subsequent cut that the dross gets less and less. And just some thoughts here is, first off, the nozzle. When I said I was using an old nozzle, I literally pulled out of my old nozzle bin of nozzles I thought were close, and this is the best one I could find. And so I think that what you'll end up getting is, as the nozzle gets worse and worse, is the cut quality on the edges kind of ripples just a little bit, as that it just doesn't control the stream of plasma going through the metal very well. I'm working here also trying to reduce that lead in and lead out kind of mark that you get on the corners. And that's just, I think, a matter of settings and not necessarily a factor of the machine like the plasma cutter or the Langmuir Systems CrossFire XR. It's really settings that I'm trying to dial those things in. I think back to my CrossFire Pro, and I really don't think there's much difference in the quality of the final cut. I think the big difference I'm noticing is that with the machine torch, I'm able to cut faster. And I'm cutting here, I get up to 55 inches per minute, which is what I used to cut 3/16 on, and I'll be ramping that speed up also. I'm cutting 1/8 inch up to 100 inches per minute. So it just cuts a lot faster, I think, with that machine torch. I was recently asked, somebody said, hey, how do you like it after owning this thing for about 6 months? Would you buy it again? I will tell you that besides moving the location of the computer, and I added a full-size keyboard, I also added a full mouse to the machine, there is nothing more I want from a plasma cutter. I think this thing is amazing. The CrossFire XR is just an amazing machine, and I am super happy with it, and I would totally buy it again. And therefore, I will cautiously say I recommend it. If you are looking to spend your hard-earned dollars, and I appreciate that it's your hard-earned money, on a table like this, I would totally recommend it. If you are interested in buying one, if you check out my description below, there's a link that takes us to our webpage.
And if you click on that, it'll give you a discount for the CrossFire Pro. I think also the CrossFire XR, about $100. Or if at checkout you use code NTD Racing, one word, it'll also give you $100 off on one of these tables. And we're affiliates, so some of the money goes to us, and we sure do appreciate it.
I hear people talk all the time about what kind of electrodes and consumables that you use. And here's what I just got a delivery of. And I get these on eBay. I use the codes that just come right out of the brochures for the Razor Weld 45. So I just buy the Hypertherm consumables. I pay for a pack of 5 of the nozzles about $28, and a pack of 5 of the electrodes, I think I paid $44. And here's, I'll show a link for where I get those on eBay. The prices change all the time. If you have a link for something that costs less, let me know and I'll let everybody else know. And if you're a supplier and you're watching this, and you're like, no, I'd like to have him put my stuff on his YouTube channel because I can do it for less than everybody else can do it. Let me know, and let's partner up, and I will start pushing your stuff, because everybody is always looking for consumables, and this will just help everyone.
Before I start this big cut, I'm going to go ahead and put in the new consumables. I usually take the cover off when I swap the consumables out on the XR. I find it just makes it a little bit easier to get to the machine.
Let's get ready to cut the parts for the spindles. 90% of the time when you're cutting something on a plasma table, you're dealing with odd shapes of metal that you have remaining. So what I tend to do is I will measure out all the stuff that I have left, and then I will put that into the CAD. So let me show you how I put that into Fusion 360 so that I nest all the things manually to fit the sheet of metal that I still have in my shop.
All right, so jumping back over to the spindle that we had on Fusion 360, now I'm going to basically lay out that sheet that I just had, and this is how I'm going to do all my nesting. So I'm going to sketch, and I'm going to sketch on this plane, which is my X and Y axis. This is what we're going to be doing our cutting on. And then I'm just going to make some squares. I'm going to make those construction lines, because I don't want these things to cut. I'm going to use them as a reference. And I know that sheet that I'm using it's going to be 48 inches wide. And, you know, it's probably the height of it is, we'll just say 48 inches. It really doesn't matter, because I'm not going to use the whole thing. What I really want to know is the spaces that are already cut out. And so now what I'm going to do is I'm going to go in there and I'm going to make those shapes that basically correspond to the pieces that have already been cut out, again, on the construction lines. And this one here is going to be 6 inches tall. And let me see, it's going to be 48 minus 4.5, which should be 43.5 by 6 inches. So I got that little piece right there. And then the other piece is going to be 24 by 6.25 by 6.25. And then now you see, here's the shapes that I've got to fit everything inside. And this piece might look like a small piece, but you know, I think it's consequential. It matters. It's a piece of steel over there at quarter plate, and those things are expensive. So now what I'm going to do is I'm going to start moving these pieces around. Remember, I kind of need to make 2 of these. So I'm going to hit hotkey M. I'm going to select this piece, cancel that. Oh, you know what I got to do? I got to finish the sketch first. Finish the sketch. Hotkey M, hit that thing. I want to make it's a body. I want to make a copy, and I'm going to move it. Now here are all the parts that I need to move around inside here. So it's really just a factor of hitting the hotkey M, picking the part I want to move, and then rotating it, moving it, and seeing kind of where it might fit. And as you can kind of see, you know, I might actually use that piece all the way up in there and kind of cut all the way up in there. So let me move these things around a little bit, and we'll figure out how they fit. Let's go throw them on the Langmuir Systems CrossFire XR and get them cut out and see how they look. Well, I think that's about as much as I can do with this. You know, as I make the second spindle, I might be able to occupy some of the spaces up in here. You know, and I really wanted to kind of try to save some room to use the 1/4 inch plate to make the axle trusses also. So, I still have some metal down here, and there's some other parts I got to make. I probably need to go buy another sheet of the 1/4 inch, or decide if I'm going to make some other parts on the 3/16, but I really wanted to make these really critical pieces on 1/4 inch plate. So I'll go buy another sheet of that. That stuff's expensive, but we'll deal with that. Anyway, I think it's a pretty good use of the space and just being able to nest it out myself. So to fill the spaces, I added in a couple more pieces here, and these are just some doublers. I'm going to weld over all the holes to make those 1/4 inch holes 1/2 inch still, and then I'll put these doublers all on there. So I just added those in there because I figure it's free space and I might as well use it for something. Anyway, let's go ahead and let me show you how I set up for the manufacturing, especially for something big like this. Let's go ahead and get into that. I was tinkering with it a little bit already, but I got all these parts there ready to be manufactured, and I hit setup. And I got to go and tell it which parts I want to actually grab. So I'm going to first, before I pick an origin, I'm going to go over here and just select all the parts that we're going to be cutting in this operation. And you can kind of see it starts building like a perimeter, a profile of that whole thing that it's going to cut. And then now once I have that, now I can go over here and say, okay, pick my box point. And that's basically the point which I will use to measure everything off of, to reference where the torch is going to basically start on there. It's going to use this box, and it's going to be up here. So it seems like this point will be pretty easy to identify because it went about 1/4 inch down from where the last cut, kind of the top of where this piece stops or whatever. So I can put it there and then track my torch around to make sure that I don't like cut into open space or something like that. So it'll be a good easy point to start with that. And then besides that, I'll just give it a name. So there, I named it. Now I'm going to go ahead and go into the cutting portion. And again, I'm trying to, I have it pretty much dialed in. I think the 50 inches per minute is pretty good. I might be able to go to 55, I think, on long runs, but let's stick with 50 and see how that works as far as the cut speed goes. And now I got to go in and tell it again, hey, we're cutting, what we're going to make cut profiles for. So you got to go back through and pick all these pieces again that we had picked before. And we're going to, if you don't pick them, it won't make a cut line on them. So there's all the parts that we're going to cut. And so now let's go through, and all these things are pretty good now. With some of the updates on Fusion 360, I guess they just, like this used to be always, it would always say in control. It's got to say in computer, and it seems like that's working now. Here's where I'm going to change a couple things. I'm trying again to get that, for the art guys out there, the lead in that kind of leaves a nick sometimes in there. I'm trying to get that down. So I'm tinkering with some different stuff there. I'm going to make a radius of 0.1, and this will be a little weird, but I'm going to go ahead and make a lead-in sweep angle of 100 so that it actually kind of sweeps in an angle and then makes a loop and spends as little time as it can, burning into the pieces it kind of goes into it. Again, I'm just messing around with it. I don't know. I think I can get away. There's little squares down here. Might have issues with a 0.2 lead-in distance. I'll try it. We'll see what it gives us. Otherwise, if it doesn't work, we got to go back through this whole thing and do it one more time. The lead out has never been working for me. They say don't do a lead out, and I tried it a couple times. I tried it in it again. I don't like the lead out just because it messes it up as it goes out, and then you got to figure out where you want it to enter. If you don't say anything, it'll pick where it's going to enter for yourself. And I don't really care on these small pieces, but for these larger pieces, again, I will kind of pick something like, when I come back around with my belt sander and I kind of grind, if it does make a nick in these spots, that to me is easy for me to just grind those off if it's on an angle. If it's on a flat piece right there, it's just really hard to kind of grind those off. So for at least those big pieces, I'm going to tell it where I want it to enter and start the cut. Let's see, especially if it'll make a cut profile for these small ones. And sure enough, it did. This might be problematic. You kind of see here as a torch fires, it drives over here and then makes this turn right here and then starts cutting. It gets really close to where this one's going to cut. So it could give me a problem here. These are just some areas where I'm going to rosette weld. I really don't care. But these, you can kind of see what I'm trying to do is I'm trying to have this thing start firing somewhere in the center of this space. So I could have gone with like 120. So it kind of goes this way and then hits that 0.1 arc and then starts off on the races and spends a little bit of time right here where it's going to kind of melt the material. So again, I'm just trying to dial it in. It may not be perfect, but after a while, I should be able to get it pretty good. So 50 inches per minute. So that looks good to me. And if you want to, again, we can run a simulation and say, hey, show me how you're going to cut this thing to give you an idea of how it's going to cut, and what kind of things might give you tip-up problems or whatever. From there, I'm going to go ahead and post the G code over to the same file folder I've been using. The 0.2, that looks pretty good as far as my pierce delay. I like that. From there, all that stuff looks good. I'm going to go ahead and post this to the fire control. Now I can go downstairs to the CrossFire XR, load this thing up, and let's try and cut this thing out.
All right, first thing I'm going to do is open up that program I have, get this thing onto the computer. Now realize it's literally the extremes, at least as far as width goes, of the machine. So what I'm going to do is just make sure that the machine knows where it is. So I'm going to hit the home, and I'm going to home the machine, which is going to send it all the way back to the back corner, and it's going to touch all of the limit switches. And it's also going to re-square the machine just in case for any reason that it's out of square. It's going to take care of that. And now that it's there, it knows where its 0 points are. And now I'm going to go ahead and bring it back, and I'm going to try to find that point. I'm going to raise up the torch here a little bit. Find that point where I decided I was going to start this thing on. I'm going to slow it down. I'm going to get as close as I can to that point that I wanted to start the cut on. All right, there we go. So now I'm going to go ahead and zero all the work axes. And then now I really just need to go and check to make sure that based off of what I think, where I think it is, that it's actually going to cut all these parts and stay in the zone. So I'm going to go back to 400 inches per minute and zoom across here. And then I'm just going to make sure that wherever that it is, like the closest, like right there, as I plunge down from here, I'm going to slow it down so I don't just go plunge right in the metal too fast, that it indeed is still cutting on a piece of metal. It's just a matter of going back and forth a couple times and checking. And it looks to me, as I kind of look at it, that it's just too close for what I like. I actually would like it to be a little bit more into the metal, just because I don't want to mess it up. It's kind of a big cut. So I'm going to go back in a second here, and I'm going to just lower it. So I'm going to go ahead, raise the torch up. And this is important. Anytime you go back and before you hit this go to your work 0, make sure you raise the torch back up. Otherwise it's going to go across. And in my case, I've lifted this piece of metal and I've bent the end of it a little bit. So some of it's a little higher than the rest of the metal. And if I don't raise that torch back up, when I hit this button, it is on the crazy train back to that beginning point, and you can't stop it. And if it hits something, then you're gonna damage some parts. So anyway, I'm gonna go back here, and I'm gonna just bring the torch this way a little bit and over a tad also. I'm going to re-hit the 0, all the work axes. I'm going to go back to 400 and check that point one more time just to make sure. I know it's a little bit tedious to do this, but it does ensure that indeed your workpiece, you're going to cut and it's going to stay in the workpiece.
All right, well, this part is this is an error I make, and so you get to see me make the error and try to fix it here. But I think this is just another amazing thing about Langmuir Systems fire control software. I nest these things too close, and as it cuts these small pieces, one of the pieces is nested so close, the whole piece drops in the water pan. So there's no metal there for it to cut, and so the torch actually plunges into the water. So what I'm able to do is go back into the fire control and say, okay, let's start all back over. I go over and I'm able to select the line where I want it to restart from. And I say, okay, let's just redo the whole program from here and then just restart the whole program over again and continue cutting. And before they had all the capability they do here, you had to go and figure out how to go and restart this thing and just redo the whole program. And being able to go into your G code and restart it just visually, you don't have to do any crazy math or anything like that, and restart the cut. I mean, it saved that piece of metal and everything, and just tons of work, and it was really easy to fix that. So I just want to show you there was a mistake I made, and just how easy it was with the fire control software to fix that mistake. Well, the rest of this process involves me just getting the stuff ready to weld and put together. And I will tell you, I spend a large portion of my life in front of this belt sander. It has been working great for, I don't know, 15 years for me now. If you're wondering where I get this, check out our Amazon store. If you go to ntdracing.com, click on the tools we use or our store and go there, and you can find all the stuff that I use throughout my shop. Anyway, from there, I show you how I get rid of mill scale. And I'm actually going to make this another video. My next video will be a standalone how to get rid of mill scale. And I use white vinegar, I use a metal brush, and I use a thing called a bristle brush from 3M. And I'll put a link in the description on all those things. It is also on our Amazon store where you get those things, but it is just amazing how easy it is to get mill scale off of this hot rolled still. Anyway, from there, it's just time to put this parts together and see how this spindle is going to look.
Okay, here's a quick look at this spindle all together, and you can kind of see what I was going for in the spindle or the upright design here, just kind of keeping the thickness here. This is probably where it's going to start to see a whole bunch of load as it diverges away from this plate right here. So we wanted to keep that thick, and that's probably a good 4 inches across right there. So I think a lot of resistance to any kind of a load that's going to be on there. It should be pretty strong. We're obviously going to plate the top of this and also the back side there. So it should give it a lot of strength in there. Anyway, this is where the caliper is going to go. You can kind of see some of the clearances. Those 4 bolts are which go into the hub bearing and hold this whole thing together. I think it's going to look pretty good. I like this design a lot better than I like the Honcho design. On this side, we still got to put in a steering tie rod landing point. It's probably going to come out over here, and it's got to sit just slightly inside the straight line between these 2 points, just to account for the Ackerman angle. So it's probably going to land right about over here, and we'll tie it all in together with that design. But besides that, there you go. That's what we're looking at. Well, I am really pleased with how the spindles are coming together. I'm also really pleased with how the Langmuir Systems CrossFire XR is working. Like I said, if you're interested in more information about the CrossFire XR, you can go to our website at ntdracing.com, click on Fab Shop, scroll down, and you'll see a whole bunch of videos of me using the CrossFire XR or the CrossFire Pro. And there's also a discount code there if you use NTD Racing. When you check out at Langmuir Systems, you get $100 off on these tables. One more time, please consider hitting that like and subscribe, ringing the bell for notification of future episodes. If you leave a comment with a question of something you want to see in the next episodes, I will surely try to do that. I will see you then. Take care of yourself.